Okay, let's dive right into this mission. In this explainer, we're going to review our rational number operations, but, through a real-world lens. We're taking everything you've already learned about adding, subtracting, multiplying, and dividing all those positive and negative fractions and decimals, and we're going to see how it all applies directly outside the classroom walls.
What happens when your math escapes the classroom and hits the real world? Well, it's a question pretty much every 7th grader asks, and honestly, it's a brilliant one. Today, we are absolutely going to answer it by applying our math toolkit to a super practical scenario. As we transition from just learning the basic rules in isolation to solving complex, multi-step word problems, we really need to make sure our foundations are rock solid. So, we're going to bridge that gap and show you exactly why these rules actually matter out there.
Here is our mission briefing. We're going to start with the rational number toolkit, tackle solving the transfer problem, learn how to avoid common math errors, do a quick check for reasonableness, and finish off with your turn, a self-check.
Section 1. The Rational Number Toolkit. Let's see how this builds our foundation. Now, what's really cool here is how we've basically packed all the rules for adding, subtracting, multiplying, and dividing positive and negative numbers into one convenient place. Remember, a rational number is simply anything that can be written as a fraction, right? So, integers, decimals, the whole shebang. A really great trick to remember here. Subtraction is really just adding the opposite. That means p minus q is exactly the same as p plus negative q. Oh, and when multiplying, you definitely can't forget the classic rule. A negative times a negative always equals a positive.
And hey, just remember, whether you are dealing with whole numbers, decimals, or fractions, the order of operations remains your guiding sequence. Parentheses absolutely come first, followed by exponents, then multiplication or division from left to right, and finally addition and subtraction from left to right. Keeping to this strict sequence is literally what prevents total mathematical chaos.
All right, Section 2, Solving the Transfer Problem. With our toolkit ready, it is time for the field test.
So the crucial point here is taking a real-world baking problem and translating it into a multi-step mathematical equation using fractions, decimals, and negative numbers. It's like a giant puzzle. This is what we call a classic transfer problem. You aren't just handed a pre-written equation to solve. No, you have to build the equation yourself based on the constraints of the real world. Let's say a recipe needs 3/4 of a cup of sugar per batch, and we're making 5 batches. But wait, there's a catch. We also owe our friend 1.5 cups of sugar from a previous baking adventure. So how much sugar do we actually need to acquire to bake our current batches and pay off that debt? Watch how these steps visually unfold. Let's move from multiplication to addition while keeping a really close eye on our units. First, we determine the total sugar for the recipe by multiplying our 5 batches by 3/4. That gives us 15/4 or 3.75 cups. Okay, step 2 brings in our debt. Now in math, debt is usually negative, right? But since we need to figure out the physical amount of sugar we have to go buy, we actually have to add the absolute value of that debt to our total. Converting everything to decimals makes this final addition so much smoother. So 3.75 plus 1.5 gives us a grand total of 5.25 cups of sugar to buy. Section 3, Avoiding Common Math Errors. We're making great progress, but we definitely need to watch out for a major trap here.
This brilliantly illustrates one of the absolute most common mistakes students make. When you're solving rational equations, you must remember that dividing by a fraction is exactly the same as multiplying by its reciprocal. So if an equation asks you to divide by 3/4, you actually flip it and multiply by 4/3. Never, ever fall into the trap of trying to divide the numerators and denominators straight across. Always use the reciprocal.
Section 4. Checking for reasonableness. Before you ever hand in an assignment, you need a secret weapon to verify your work.
By checking your estimation, units, and signs, you basically become your very own answer checker. Let's break down this checklist, shall we? First, did you estimate? In our baking problem, 5 batches at almost 1 cup each is roughly 5 cups, plus about 1.5 cups owed, so our answer should logically be somewhere around 6.5. Second, are your units correct? Well, we're measuring in cups, not batches. And third, does the sign make sense for the context? For instance, if your calculation for the baking problem somehow resulted in negative 3.75 cups of sugar, your reasonableness check would immediately tell you something went wrong. I mean, you literally cannot go to the grocery store and buy a negative amount of sugar. A negative result in a physical, real-world constraint problem like this means you probably subtracted when you should have added, or maybe you just lost track of a negative sign along the way. Always pause and ask yourself, does this number actually make sense in the real world? Section 5. Your turn. A self-check. You have the tools, you know the traps, and you know how to check your work. Now it is time for your final challenge.
Go ahead and grab a pencil and try solving this one-step equation using what we just reviewed about inverse operations. The equation is 4x equals 2/3. Think about how to isolate that x. You have a whole number multiplied by a variable, and it's set equal to a fraction. So which operation is going to undo that multiplication? And how do you apply that to both sides to keep the equation perfectly balanced? Go ahead and mentally compute it or scratch it out on paper. I'll give you a second. All right, if you remembered to multiply by the reciprocal to get 1/6, fantastic job. Seriously, well done. To isolate x, you needed to divide both sides by 4. But remember our error trap from just a minute ago? Dividing by 4 is the exact same thing as multiplying by its reciprocal, which is 1/4. So 2/3 multiplied by 1/4 equals 2/12. And that beautifully simplifies right down to 1/6. This just goes to show you can totally navigate one-step equations dealing with rational numbers and fractions.
As we wrap up this explainer, I want to leave you with this question to chew on. Where else in your daily life do negative signs or fractions completely change the meaning of your numbers? It happens all the time in bank accounts, when a balance drops below zero, or when you're scaling up recipes for a huge party, or even when temperatures drop below freezing. Think about that for a bit, and keep looking for the math hiding in the real world around you. Stay curious, keep estimating, and we will catch you next time.